Alright, a few more of the Vsepr ones. This is methane, which we kind of already looked at. But again, methane is pretty simple. And what we are looking at here is, again, that central atom of carbon. So again, first thing you find is that on carbon I have 4 bonding areas. I have no lone pairs, so I have no non-bonding. And then again, what we're doing is we're looking at our chart. Oh, I totally typed 1 instead of 0. Sorry about that. See, this is why I need to be there so you can yell at me. We go to our chart. We find an area with 4 and 0. We're based on a tetrahedral, and we are an actual tetrahedral. And that's the normal name. You may have heard of it, or you may have heard of it. Sometimes people call it like the lunar lander, because it kind of looks like something that would land on the moon. And that means we are electronic of tetrahedral and molecular of tetrahedral. Next one is ammonia, and again you're doing it based off of nitrogen. So we have 3 bonding areas. We have 1 non-bonding area. You go to your chart. You find your 3 and your 1. We're still based on a tetrahedral, but now we're called a trigonal pyramidal. So you have like a little 3-sided pyramid pointing down, and you have the lone pair pointing up. And so electronically, we were tetrahedral, but molecular, we were a trigonal pyramidal. If you look at water, again, we kind of already did it. He has 2 bonding areas. We have 2 non-bonding areas. So again, you go to your lovely chart, and you find 2 and 2. So again, we're still in the tetrahedral world, but we are now bent. And what you'll notice is this is the same shape as the 2 and 1 from above. So we are based electronically on a tetrahedral, but molecularly we are bent. And last one we're going to do as a group is this guy right here. So I did the need available share here, and you're welcome to write it down if you want to. You can pause the video or whatever. But one thing, you have to have the right Lewis structure. If you don't have the right Lewis structure, you're going to have the wrong shape. So one thing here, I did my need available share. I only ended up needing 3 bonds, and that definitely indicates that I had high prevalence. And you'll notice that iodine is holding 1, 2, 3, 4, 5, 6 sets of electrons. So he is at 12 electrons. So he's a very unusual one. Again, if you don't have it right, you're not going to get the right shape. So we have 5 bonding areas. We have 1 non-bonding area. And we can come up here, 5 and 1. And that means we're based on an octahedral, but we are a square pyramid. And that's what we are. So electronically, we are an octahedral, but molecular, we are a square pyramid. And again, this is stuff you really have to visualize. Like I said, there's great things on the internet to kind of go through this and understand this. If you're really spatial, you may see it. If you are not, you need to go online and look at them. And I'll just show you my favorite one. This guy right here. His name is Seesaw. He's 4 bonding and 1 non-bonding. And if you actually build him correctly, he actually does make a seesaw, and he actually goes back and forth. And here you can see we have a T-shaped, which is kind of nice. And one thing you'll notice on this one, where trigonal bipyramidal, you'll notice that for the bipyramidal, you start taking from the central area and not the poles. Whereas if you're looking at the octahedral, you actually take from the poles first. So that's something you need to make sure you learn and remember, so that you can kind of see that. And the last slide for this section is, I just want you to be aware, is when you have larger molecules, you actually have shapes based on different areas. So if you look at acetic acid, this is a drawing of acetic acid, you would have a shape on the first carbon. You would have a shape on the second carbon, and you would have a shape on your oxygen. So if you look at this first carbon up here, he has 3 bonds to hydrogen and a bond of carbon. So he's a 4 bonding area, 0 non-bonding. And when you look that up, he's tetrahedral. When you look at the second carbon, he has 1, 2, 3 bondings. Remember, the double bond just counts as like a bonding area. So he's a 3 and 0, 3 bonding, 0 non-bonding, which means he is trigonal planar. And very last but not least, now be careful because these electrons were not shown. I obviously added them in. But we have 2 bonding here on the oxygen, 2 non-bonding here on the oxygen, which means he is bent. So each of those individual things has their own individual shape. And when they go together, you start getting much larger molecules, which comes into a lot of play when you're dealing with like DNA and that kind of stuff. So just be aware of that when you're doing it.